Hello, my name is Ryan Schosberg, and I'm a researcher with the Center for Coastal Studies Right Whale Ecology Program. This is my presentation for the 2025 North Atlantic Right Whale Consortium meeting. Today, I'll be talking about right whale site fidelity to Cape Cod Bay and how this fidelity is influenced by animals' calf-year exposure to the bay. Please don't share any of the content seen here on social media, please. Cape Cod Bay is a crucial spring feeding habitat for endangered North Atlantic right whales of all demographics in the winter and in the spring months. The bay is also visited by many right whale mother-calf pairs when the calves are around 3 to 6 months old. At last year's consortium, I talked about how we've been seeing a large proportion of mother-calf pairs over the last decade, and their residency in the area also seems to be increasing. It also seemed like we were seeing many of these calves return the following years, so here I wanted to investigate if the early life exposure to this habitat influenced site fidelity, explore if calf year exposure to the habitat influences any intra-seasonal temporal trends for these animals, and see if any of these patterns persisted through multiple life stages. To investigate these questions, I'll be using CCS aerial survey data. I won't be discussing any data from other institutions or platforms today. CCS has been flying line transect surveys in Cape Cod Bay since 1998. The black lines on the map show our typical survey plan, which has remained largely unchanged since the start of the program. I'll also be using this area shaded in red as the definition for Cape Cod Bay. So I compiled all of the right whales born from 1998 to 2024 with known birth years. Then I compiled all of the years each of those animals was confirmed or presumed to be alive. Then I reviewed our aerial survey data and binned all of these individuals based on if they had been brought to Cape Cod Bay during their calf year or if they were not observed in Cape Cod Bay in their calf year. Then I queried our aerial survey data set to review if that individual was observed in Cape Cod Bay for each available year of their life. For years when they were observed in Cape Cod Bay, I also put together the date of their first sighting in Cape Cod Bay, aka arrival date, the date of their last sighting in Cape Cod Bay as a proxy for departure date, and residency time, here defined as the number of days between the arrival date and the departure date. Please note that at the moment, we do not account for animals that may have left and then returned within the same season. I'll also be binning animals into age classes. Juveniles are ages 1 through 8, and adults are ages 9 and up. So this is what this raw data looks like. Here, age is on the x-axis from 1 to 20, and the y-axis is the percentage of animals that were sighted in Cape Cod Bay for each of these ages. The blue line is tracking the Cape Cod Bay presence rate for individuals that were seen in Cape Cod Bay as calves. And then the orange line is tracking Cape Cod Bay presence rates for individuals that were not observed in the area in their calf year. I've also included a few N values showing the number of individuals that were able to contribute to the data set for each category and age combination. For reference, there were 94 individuals that were seen in Cape Cod Bay as calves, and then were presumed alive as yearlings, and 50% of those animals were sighted in Cape Cod Bay at age 1. Conversely, there were about 245 individuals alive that were not observed in Cape Cod Bay during their calf year, and only 22% of those animals were sighted in Cape Cod Bay at age 1. You can see that these N values decrease over time, partially due to animals dying off, but primarily due to animals born more recently not having the opportunities to reach these older ages yet. You can see some of the data gets a little bit noisier as we reach these higher ages. And then for context, these are the demographic age groupings that I'll be referring to for the rest of this analysis. Again, juveniles are ages 1 through 8. There were 339 individuals that contributed at least 1 year of data to the juvenile return rate dataset for a total of 2,106 years. Then the adults are ages 9 and up, and 109 individuals contributed at least 1 year of data to the adult return rate dataset for a total of 1,497 years. When I say years here, I'm referring to the cumulative number of years that all the animals in each dataset were alive to contribute to the dataset. So for example, an animal born in 2004 that is still alive at age 20 would have contributed a total of 8 years to the juvenile dataset and 12 years to their respective adult dataset. And another example would be an animal born in 2020 that is still alive at 5 years old would have contributed 5 years to their respective juvenile category bin. A few things that jump out. The return rate for individuals with calf year exposure to Cape Cod Bay, the blue line, is noticeably greater than those without the Cape Cod Bay calf year exposure throughout the juvenile years. The rate of return for those individuals without Cape Cod Bay exposure during their calf year increases throughout the juvenile year, and then at age 9 is very similar to that of the other group of animals that did come to Cape Cod Bay as calves. So here we're looking at that exact same data, but now I've binned it into age class categories displayed in a sort of chi-square mosaic plot. To orient you to this chart, vertical segment size is proportional to the number of available animal years that contributed to each of these 4 animal categories. For example, the category with the most years available to bin was juveniles not observed in Cape Cod Bay as calves, so it's the tallest box. The category with the least available years to bin were adults that were observed in Cape Cod Bay during their calf year, so it's the shortest box. Then, the horizontal width of the box of each segment is relative to the proportion of years those animals were observed in Cape Cod Bay on the left and the proportion of years that they weren't observed in Cape Cod Bay on the right. The colors represent the degrees of deviation from expected proportions if these factors were truly independent. So darker greens are an overrepresentation and darker reds are a stronger underrepresentation. So here we see that whales documented in Cape Cod Bay as calves returned during their juvenile years significantly more than those without calf year sightings. Adults with calf year exposure to Cape Cod Bay did still return to Cape Cod Bay at slightly higher annual rates than adults that weren't brought here as calves, but this difference was very small and not statistically significant. Changing gears a little bit, the rest of these slides are looking into when these different categories of animals are in Cape Cod Bay for the years when they are present here. We're looking at arrival dates to Cape Cod Bay, aka the date of first sighting each year for each individual, binned into those same four age categories we just looked at. So the top are individuals without calf year Cape Cod Bay exposure, yellow being juvenile years and orange being adult years. Then the bottom two rows are data for individuals with calf year Cape Cod Bay exposure to Cape Cod Bay, light blue being juveniles and dark blue being adults. Each of the four categories has a scatter, showing the real day of first sighting for each of those individuals when they're here, a half violin plot with a height proportional to the density of the arrival scatter points, a box plot showing the median arrival date with interquartile ranges for each of those animals, and then an n value on the right to give you an idea of the number of animal years available for each category. Day of years on the x-axis, and it stretches from our typical survey season, January 1st through May. You can see that the bottom three categories appear to have relatively similar arrival times, with the juveniles with Cape Cod Bay calf year exposure trailing just a bit behind the adult groups. But then the large outlier appears to be juveniles without Cape Cod Bay calf year exposure at the top, which has a large density of late season arrivals in mid-April. You might also notice that the adults without Cape Cod Bay calf year exposure seem to have more peaks and more variable peaks in arrival dates than the other two groups. And the statistics largely support what we're seeing here. There's a significant difference in arrival dates between these categories, and it's driven primarily by the date of first sighting for the juveniles without Cape Cod Bay calf year exposure. Their arrivals tended to lag 1 to 2 weeks behind the three other categories on average. There weren't any significant differences in arrival dates when comparing any of the other groups. Here we have a very similar chart, but instead of first sightings, we're looking at last sightings as a proxy for departures from Cape Cod Bay each season. All four groups had very large peaks in the last sightings for the season around the last week of April. It appears that age class is a stronger indicator for how late into the season individuals remain in the area than calf year Cape Cod Bay exposure, which isn't too surprising. The mean days of last sighting between the two juvenile groups is less than 2 days apart, and the mean difference between the mean day of last sighting between the two adult groups was less than 1 day. This is also reflective of what we see firsthand in our surveys. The last animals we tend to see in Cape Cod Bay at the end of each season are the very young animals and the mother-calf pairs, so it's cool to see that represented here. And it's also an important reminder that some of the most vulnerable individuals are the last animals we see using this habitat. And the statistics partially support this. Both of the juvenile groups' last sighting day in Cape Cod Bay was significantly later than the adults without Cape Cod Bay calf year exposure groups. However, we were unable to definitively say that the significance also applies to comparing juveniles to the adults with Cape Cod Bay calf year exposure, though this appears to be due to a lack of power due to the relatively small sample size within this adult group. It seems like 121 data points is not able to detect a 5 to 6 day lag in mean dates for these sightings, so this would be interesting to revisit in the future. Moving on to our last result, here we're looking at residency time, again defined as the number of days between the first and last sighting of an individual within the season. The y-axis has our same four categories, but note that the x-axis here is a measure of days rather than dates. The apparent trend we see here is that animals with calf year exposure to Cape Cod Bay tend to spend more time in the area when they're present. And within both of the calf year exposure categories, the adults tend to stay later than their juvenile counterparts. And this is largely supported by statistics as well, with juveniles without calf year exposure to Cape Cod Bay spending significantly less time in the bay than individuals that were brought here during their calf year. Mean residency comparisons between any other groups were not statistically significant. Wrapping things up, calf year exposure to Cape Cod Bay appears to be associated with increased presence, earlier arrival dates, and longer residency durations in the bay during the juvenile years, but this does not necessarily carry on into adulthood. Juveniles also tend to linger in this habitat for about a week later than any of the adult categories. These findings provide insight into feeding habitat fidelity in these endangered animals and highlights the need for management measures that account for demographic factors to help protect the population's most vulnerable individuals.